No, Jyoti is not here. I don't know. She didn't come today. Yeah. So access modifiers, there are four. Public means everywhere. So a class can be public, a variable can be public, a method can be public. Private means inside the class only. So generally when you write private, you will write method and variable only private. So class can be private. Okay, class can't be private. Default means within the package only. Means if you have a package, if you are writing something, it's there only. Like for example, a variable can be default, so I can use it in another class. A class can be default, I can use it in the same package. Outside the package it cannot create an object. If a method is a default, this method can be seen. So this access level can be at the class level, method level, or variable level. Protected means same like default, it's default plus, so everyone in my package, even though child or not, but outsiders only childs can see it. These are the access modifiers. Okay, some people will call this one as mostly they are access modifiers only. There are different names for that. Sometimes interviewers will ask like, do you know some other thing like access attributes or something, you should tell this. I don't know, I don't remember, but some other had other names too. Okay, now we will come to an important concept of polymorphism. Okay, employee is equal to new employee, you can write that. Manager M is equal to new employee. Manager is a employee. Do you agree with me? Is employee a manager? No, every employee cannot be a manager, but every manager is a employee. Is every int a long? Is every integer a long? Is every long a integer? No, you cannot guarantee. Might be, might not be. I don't know. Every integer fits into long. Every integer is a subset of long. But a long can be outside this subset. So that is why you can't tell it. So every manager is an employee. Only some employees are managers. Every integer is a long. Only some longs are integers. Okay. Can I write this? Another pointer. Okay. Can I write this? Second one. Who is the object here? Can an employee come into manager? No. No. Manager, every employee, this is an employee. You cannot put it into manager. For example, you have a manager. Can you see him as an employee? Yes. Okay. So, a bigger object can become smaller object. Here means like, what it is happening here is, when you have a manager object, manager is a employee. Agreed? So what does he have? Employee ID, employee name, salary, and also he has department. So when I put the manager reference is the type. When I put it in the manager reference, I can see everything. When I put the same object into an employee reference, I can only see employee part of it. Understood? Understood? I'll tell you one thing. For example, you are going to For example, you are representing your father, right? You can go to your father's party instead of, means they send an invitation card to your family. They'll send your last name. They will not send your full name and everything, right? To the family, right? And you are representing your father. Will you ask like, how are your friends? No. You are representing your father. They will only ask about your father, means attributes you inherited from your father. They will not ask attributes you yourself built up because they don't know you. You are representing your father there, your parent there. Agree? So, you didn't get it. No problem. It's okay. So, for example, see, a child is there. Child inherited everything from the parent. Child also has his own stuff. Child has his own stuff. So, child is a greater set than parent. Only other than private, but he inherited everything else. He got everything for free, right? He got everything for free. He has more than what he earned, right? So when you have inheritance, you are getting for free. That is the use of inheritance. Otherwise, there is no point of inheritance, right? So you are getting everything for free. So when the child is representing parent, child can go to somewhere and represent the parent because he inherited. When they see, he acts like a parent. They don't know about what he built up. They only know about the inheritance. Only the attributes which are inherited from the parent. So when you put this manager object and put it into employee reference, when you take a manager object and put it into employee reference, he will behave like an employee. He is not manager. Will not, we cannot see it, but they are there in the memory. For example, when you say em dot department, you can't see. But same thing, for example, instead of doing this, if I write this manager pointer, just changing the pointer type, em dot department is access. So by putting an object, that object is manager object only. That object is manager object. By putting it into parent reference, he is acting as parent. By putting it into child reference, he is acting as child. Is this polymorphism? Behaving differently, one object behaving differently? That is polymorphism. Polymorphism is nothing but exhibiting different behavior depending on using something. So here, using the reference type, by changing the reference type, this is called polymorphism. So Ramani, you got it or not? Yes, no? Okay, all right. So we put this guy in employee, right? So we will only see, and another thing, I will write this as get manager details for now. Okay, get manager details for now, right? So when I write, so em dot, when I print get details, so when I say sys out, when I say em dot get details, can we see actually, so what is polymorphism? I will change this to employee. Okay, so and if I, what did manager write for himself? He wrote these two things for himself. Everything else he got from employee. He wrote these two things. So you can't see that. You can't see. He will just behave like a plain employee. So what you will do, sys out and em dot get details, right? And if you do em dot department ID, it will not match. So this is polymorphism. Okay. He's behaving like an employee. Now this guy is manager, right? But he's still manager, right? Now I want to back him to be manager. You need to take this into put it back into manager reference. So how will you do it? You will put it back this to, let's say here, you want to put this back to manager reference, right? Manager reference, manager, let's say MA1 is equal to EM, right? EM. So you are taking the this pointer and putting back into manager, right? But is there any guarantee this pointer is pointing to manager? It can't be pointing to just employee. Agree? So any parent, when you are putting the parent into child, it won't go, because there is no guarantee is child, is he really a parent or is a child acting as a parent, right? For example, a child went to parents party, he acted like his parent and came back. When he's coming back into the child's party, is it really parent coming or is it really child coming? Understood? Like his friends will stop him, really prove that you are the child, because you know your father might be coming to the party instead of you, right? So a child cannot, so that is the reason you need to do casting. So you need to do casting. You are converting it into manager. If this guy is not really a manager, it will fail, because a child can never become a manager. For example, see the same example I will tell you. Let's say employee E1 is equal to new employee. This does, which object I created? Employee. Does he have department ID? Does he have that get manager details method? No. So can he ever become anytime manager at all? The object is employee, right? So see, when you have manager object, you have everything employee have. So you can become employee. You can mask like employee. You can, show up yourself like an employee, because you have everything employee has. But when you create an employee object, does he have anything of manager? He does not have manager stuff. He can never become manager. So for example, if you do like manager M1 is equal to E1, by default it won't happen. Even though you force it, bring it, this will fail at runtime, because there is no department ID in it. This will fail at runtime. Okay, so this guy can never become what? Manager. But here a manager went as child, he can come back into manager. So you will force like MA is equal to manager. This will pass. Why? Because really it is a manager who is acting like a employee. It is really a child who is acting like a parent. So there is child, there is manager in it, there is department ID in it, there is get details in get manager details. So it will cast it into manager. One is upcasting, one is downcasting. One is implicit casting, one is explicit. Implicit means it automatically happens. Means you can put a manager into employee, does not matter, because every manager is an employee. So remember, we can put all managers into employees. Why? Every manager is an employee. It's implicit. You don't have to force it. When you are putting a employee into manager, you have to force it. That is explicit. That is explicit casting. Agreed? Because there is no guarantee there is an employee or manager in it. Agreed? Understood? So this is polymorphism. A manager can become employee, and he can become back into manager too.
So in the same way, like you can convert this int and long also. Like
Int and long are also done. It's very simple. It's not this complicated. Yeah, it's already done. Yeah, yeah. If you are putting a integer into long, you can directly put it. If you are putting a long into integer, you never know it will fit or not. You will truncate, you will force it and put it. You will force it and put it.
same way
You can put a You cannot put j like that. So what will you do? You will cast it into int. Agree? This will run fine because it's in the integer range. But if it is beyond truncated, if it is beyond integer range, it is truncated. Similarly, this will work fine. But if it is not really a manager object, it will fail. Of course. That is called, no, not out of bounds is only for bounds when there is arrays. It will throw an exception. What kind of an exception? Not range. It's a type actually. Yes, parent cannot be child. Child can be parent and child also. A parent cannot be child. A child can be parent and also child because child is inheriting. Parent is not inheriting from child. Child is inheriting from parent. So who can be whom? Right? Why do we need? Okay, very good. In real world, there is a really good advantage with inheritance, right? But what is the really use of this one in Java?
You can use already the existing.
For example, there is a program. There is a program for bonus and everything. You can write a function. For example, let's say everything bonus and everything, like let's say public static void bonus and everything. He will take employee pointer. In that employee pointer, I can pass manager, I can pass director, I can pass CEO, CTO, because everyone is an employee. He doesn't know which one I am passing. He will never see it. He will never see it because he will only see them as employees. I can have, for example, my CTO has this much, some other things. I don't want to show him. Am I showing it to him? He will never know. Dependencies, programs, dependencies. I can still have my own, but I will only show you what you needed. Right? For example, that is how, means programs talk on base layers, not on top layers. We create parents so that, the application is a base class, that is called base classes. Base class means that is the class for the general purpose. That is the class for general purpose, means for communication between programs. But you can pass anything into it. You can pass, for example, into this one, I can pass manager, I can pass anything. Right? So, even though my manager is an employee, he gets bonus and everything. So, I don't need to write a bonus class for, bonus method for manager separately, bonus method for employee separately. Everyone will get that. It's not only inheritance. If someone is accepting the parent, they will accept everyone. I don't need to write that again. Agreed? So, that is one thing. So, then, there is one more advantage, and we are not duplicating code. We are not duplicating code. We are using this feature. Agreed? And we are masking objects when needed. We are hiding them. So that is the main advantage. Okay. The next advantage is overriding. Views of, so now see, is polymorphism possible without inheritance? No, polymorphism is not possible without inheritance. This polymorphism is not possible without inheritance. There is the next one called overriding. For example, if you have, see this method, so yes, can be used as parent when put it in parent reference. Okay. So tell me, if you see a method, if you see a method has this access modifier. Every method has this access modifier. It may not have default access modifier also. But a method will have return type, method name, and parameters. Right? So generally, every method, there is something called method signature. Method signature is nothing but method name plus parameters. Okay, number of parameters plus type of parameters. Okay, so you will tell two methods have same signature if their method name is same and the number of parameters and the type of parameters is same, right? So that is called method signature. So method signature means every method has a signature, means unique signature. It can't be, it's a unique signature for that method only. So when you have the same method name and stop. Now, if you see here, see, this is get details. This employee has get details. What is the method name? Get details and no parameters. Is it signature? Get details and no parameters. In manager also, we wrote get manager details. It's also get details. Why do we have to write get manager details? It's get details only. So, remember, see, in inheritance, say tomorrow, like we get so much stuff from inheritance, right? Is there any guarantee? Sometimes we don't like what we have given, what we are given. We will change it, we will override it. I don't want this. For example, if they give you a car, you'll override the car, right? You don't want to use that car. You will change it, you will change the color, you will change everything. You'll change everything, right? Means you want to have your own taste, right? See here, for employee get details means what? For employee get details means employee ID, employee name, salary, because that is his business. He has only this one. For manager get details means what? He has a department also. He wants to add department. So you should use the same signature. You should override. I don't want to use it. So when you write the same method, will you get that method here? No, you won't get it. Means I don't want it, I want my own, you don't want to take it. So when you use the same method signature again in the child class, so rewriting a method with same signature in child from parent is called overriding. Got it? It's called overriding. Why? Because child does not want to use it. Child does not want to use it. That is called overriding. Okay. That is called overriding. So now see this. Employee is put in employee, right? When you do e dot get details, you did e dot get details. Which get details is calling? Parent one. Is there a department ID in it? No. Child is in child. Child acting as child, right? And you will call get details. Which get details you are calling? Means child get details. You are calling his own get details. Child put as parent. Child acting as parent. And you are calling get details. Which method will be calling? It will go to parent and it will be redirected to child. Because its object is child. Object is child. Even though child goes to parent's party, if he has phone number, he can't give his father's phone number. Right? Right? Even though he is acting as parent, his own stuff will show up there. That is called, so when you because the child did not inherit, he overridden the phone number. He said that I don't want my father's phone number, right? So he took his own phone number. So but there is a link, so he overridden, only overridden methods are redirected. So now remember, same example, public static void bonus. This guy will take everyone as an employee. He does not know someone has department ID also. But when he calls get details, get details, what happened? He's calling the new method, not the old method. Understood? He's calling the new method, not the old method. Am I right? For example, if I pass here, for example, if I pass bonus and EM, I'm passing EM. Who is EM here? Manager. What is he printing? Manager details. There is department ID also. There is department ID also. Does this guy ever know that there is a department? This means he never know. So when you update a software, there are bugs. You want to update a software, but no one should feel the change. Everyone should get the change. You will override that. You will create a child. You will override the functionality. You will update it. Overriding means everyone will get the new method. They don't even know that. Got it? That is how software updates and everything happen. Because there are so many people dependent on my code. Everyone will get the latest even though they don't know it. Because they are overriding. Yeah. So that is the advantage of overriding. When you override, this is called virtual method invocation. This concept is called virtual method invocation. When you override, when the child is acting as a parent, even though you call the method on the parent, it is calling the child method. Okay, that is called virtual method invocation. This is the toughest concept in Java. Okay.
Overriding is always called virtual method.
No, when you call the child method, when you call the parent method, it is redirecting to the. See, you have overridden get details. Overridden get details. But when you are calling here on the parent, it is going to child. That is called virtual method invocation. Overriding means writing again is called overriding. Okay, writing again is called overriding. So, if you know until here, whatever I taught until here, you can clear 70% of Java interviews. If you really know whatever I taught until here, everything I taught until here, you will clear 70% of Java interviews. Invocation. Yeah. Virtual method invocation is when you invoke a virtual method, the overridden method is called. So if you call a method on the child object, if you call the parent method on the child object, child's overridden method is called. Got it? Means it is a redirecting. Okay. Means remember, these are all interview questions and these are concepts too, both. So I am putting it together in both ways. So it's up to you. Okay. See, they're like, if you nail it down, there are 10 concepts until now. Really nail it down, there are 10 concepts. Even though you take 2 days, it only takes 20 days for each concept. Done. You don't have to go back again. Because anyway you will work, if you clear the interview, you will work, you will have to learn it at that time. I'm not encouraging you to learn at work, but what I'm trying to tell is, languages cannot be learned until you really use it. You'll learn it now, you'll learn the concept and everything, but you really cannot apply until you really see the usage of the application. Okay. And Madhu, actually I will continue this class for 15 more minutes and I will take dinner after that. So can we do a little late, like 9:45 or something? I will be available if you are okay with that. I want to continue this class for 15 more minutes. So you can come back if you are okay with that. Okay. So when an employee became manager and then manager is assigned to employee, when you call details of an employee, we get the department ID too, if I understood right. Yes. If a child is acting as a parent, if you are asking for information on the parent, if the child overridden, for example, parent gave car to child. Got it? But this child did not take the car as it is, and he changed everything. He changed the color, he made the 4-door to 2-door, and he made it to a sports car and everything. And child went to a parents party, and that friends of the parent asked him to bring the car so that we can go. Which car will he bring? Simple. He has overridden. Not enhanced. It does not have to be enhanced. It's overridden. And that's it. Okay, so there is one more thing. What does this represent? What does this represent? Current object. For example, in a method, if I say this dot employee ID, this employee ID. Okay. So, when you are in a child class, see, always child is special. Because he has, see, everything over inheritance, polymorphism, child is special. Parent is not special actually. So, because he is the one who is inheriting, everything features are on child only. So, when there is child object only, you will get all the features. When the parent object, you won't get anything. Okay. So, it's always child object. But he is acting as parent, he is acting as this one, so reference is different. So, when the parent child class is there, when you say this, you are seeing as child object. So, you will see department ID and everything. If you just want to see the parent stuff, you have to use super. Super means only parent stuff. See, but when you see this dot get details here, get details, whose get details you are calling? Child. When you are using super dot get details, whose get details you are calling? Parents. In a child you can see, even though overridden, so for example, I will write here, see, this one, super dot get details plus department ID. He is just adding to the car. Agree? Get everything from my parent. I don't have to write it again. Just attach. Got it? So super will give what? Parent. A child will inherit everything from the parent except what? Privates. And I wrote one more thing too. Constructor. Constructors are not inherited. But I did not write constructor here. If you don't put a constructor, who will put the constructor? Compiler will put the default constructor. If there is no default constructor, so is there any constructor here? No. Compiler will put the default constructor. Like this. But compiler, if there is a child one, compiler will put a call to the parent constructor also like this. Default. Every parent constructor should call child, every child constructor should call parent constructor. So if you are not putting any constructor, it is calling the default constructor. Agree? But what if parent does not have default constructor? You wrote some constructor int employee ID. If the parent does not have default constructor, am I making sense here? Parent does not have default constructor. Means will the compiler put the default constructor here? If the parent does not have default constructor, can a compiler put a default constructor in the child also? Child will also not get the default constructor. You have to explicitly write the constructor. The child class will not compile. It's up to you. You can write a default constructor and put something, or you can write again int employee ID again, and you have to pass this to parent. How will you pass it? Super. Got it? You have to pass this to parent. Super. So if the parent does not have default constructor, child will not work. Child, you have to write a constructor and you have to put a call to the parent constructor. Otherwise it will not work. This is also famous. If they ask you this question, that is a complex Java interview. Means if they went this far, they might go much far too. Okay. So this is means these are the boundaries, like where you will stop in the interview. You can't go far. Okay. Super. and I will ask you, in somewhere in my previous recordings I wrote 3 uses of this keyword. Okay, 3 uses of this keyword. Write it, find it out. Okay, yeah, you were asking something special.
Is any difference between we write the constructor, the compiler?
Compiler can only put default one without parameters, plain vanilla versions. If it is not plain vanilla, it can't do anything else. Understood? The employee is changing, it's not default one, so compiler can't help you. If you write anything, compiler will never put one for you. Agree? Now I will tell you one thing. Let's see another example. This is, I want to create an employee array. Employee array, my employees is equal to new employee array. I want to put 2 employees in this. In an employee array, like first employee, can I put new manager? Can I put a manager into employee array? Yes, you are putting an employee pointer, you are casting the same thing. Remember? Casting employee, manager to employee. So, and I can, in an employee array, there can be one employee, one manager, one director. So, when you have different types, but belonging to same inheritance, that is called heterogeneous collections. Means if you have an employee array, don't expect there is only employee only. There might be a manager, but everyone is an employee. Everyone is an employee. Remember, inheritance is called is a relationship. Means wherever you can read, manager is an employee, checking account is an account, mortgage is an account, right? Instructor is a faculty. So wherever you can put this is a keyword in English, there is inheritance there. Understood? Read it in English. Manager, what is manager, what is employee? Manager is an employee. So if there is an is a, there is inheritance there. So that is why it is called a is a relationship. Okay. Inheritance will be on different classes only. Within a class you can't inherit. It's yours. You can't yours. You can't inherit yours. You earned it. You are that. You are that. So you can't inherit yourself. You have to inherit. Someone else will inherit from you. Heterogeneous collection means a collection, generally a array of reference types is pointers. Employee pointers are there. So one can be of child object, one can be of parent object. So when an array contains some child objects, some parent objects like this, that is called different types of objects is within the same inheritance, that is called heterogeneous collections. So here in this method, everyone is coming as employee. A manager can come as employee, a director can come as employee, a CTO can come as an employee. I want to find out if he really is an employee or a manager or a director. How would I do it? There is a operator actually, that is called instance of. Instance of manager means it will tell you really if the object is a manager or not. So that then you can do casting. Manager M is equal to manager of E. Got it? You are putting it into employee and then you can do manager dot something like anything you want to do. Instance of operator will tell, if you give a pointer, it will tell if there is a child object or a parent object inside that. You have to give the type. Instance of operator. So this is very helpful. Okay. Yeah. So you understood what is polymorphism. Polymorphism is nothing but casting the child object into parent reference. So it behaves like a parent. We can't see anything child. That is the best form of polymorphism. There is another kind of polymorphism that is called overloading. Whatever we did is called overriding. Overriding means child is overriding the parent stuff. Overloading means within the same class. Perfect. Very good. And really I am very glad about this batch actually. And many of you will become Java testers for sure. I will make sure that will happen. Okay. Means some of you might take time here and there, but you have that aptitude. What I'm trying to tell, don't want to force you in something like that, because you'll have bright future for sure. No doubt about that. You will be QE, not QA, quality engineer. You will be part of the development team and stuff too. But you won't be really doing development. Okay. So trust me, and I will make sure that when you see from now here in like couple of years from now, that should be 6-figure salary. Don't compromise on that. Compromise now. Okay. But after a while, don't compromise on that. I'm telling you this to every student that because you are just like a developer. You should not compromise on that. It's easy to find developers. It's not easy to find QEs. Because those who know coding will not compromise for a tester, right? You can't find that small line, so take advantage of that. You are more worth it to the company than developer. Developer codes it, he never tests it. You are giving quality, right? You are coding too, so you are more worth it to the companies. Means it's hard to find them. Okay, yeah. So coming back, so this is the cheapest form of polymorphism. Overloading. What is overloading means? For example, overloading means, see, I have an employee class. This is, for example, I will write a small example. I don't like this example. Let's say class. There is a math class. Let's actually my math class. I wrote my math class. Means I will write all operations like public int add, int a, int b, return a plus b, and I will give you, I can use this for int c, return a plus b plus c, or I can use this for double. Got it? Right? This will give double. Okay. Within the same class, there is no inheritance here. Within the same class, you can use the same name, add, as long as the signature is different. How can a signature be different? By changing number of parameters or type of parameters. So, written type is not part of signature. Okay, that is the difference. Yeah. So, overloading means methods in a class can have same name as long as the signature is different, right? That is called method as signature is different. So number of parameters, type of parameters. Okay. All right. So that is the add method is one thing. Println is the best example of overloading. There are so many printlns. For example, if you write system dot out dot println, see 1 2 3 4 5 6 println methods, that is called overloading. Then there is something called operator overloading. Remember I told you this. What is operator? This is called method overloading, right? Method overloading. Then there is something called operator overloading. What is that operator overloading? Plus sign. Plus sign, if it is between two numbers, it will do addition. If it is between two strings, it will do concatenation. So it is behaving differently. That is called operator overloading. Then there is something called constructor overloading. Constructor overloading. You can have multiple constructors, right? Constructor is also a method. For example, you can have another constructor, right? And int employee name. See, this is called constructor overloading. Agree? If you have multiple constructors, see, for example, see here, see this example. For example, this is int add a plus b plus c, right? I can do add of a comma b and add of, you understood what I did? Add of int a plus b is nothing but give it to this one, it will add a plus b, and give the result plus c to this one, it will give this one. So I can call a method from another method because it knows that only two parameters, two integers, it will call this one, it won't call this one because it is integers, right? It finds the signature match and it will call that one. If I want to call this constructor from here, I have done already overloading. For methods also I have done overloading. So when you have overloaded methods, you can call another method from this method because it will match the signature and it will call the other one. But when you are calling a constructor, I want to call this constructor here. This. Got it? So it will call the above one. Got it? This is used to call a constructor from another constructor too. Three constructors? Yeah, you can call you can put another, means, I didn't understand. Okay. You can only call one constructor. You have to call the other constructor from another constructor. And the constructor call should be the first line. It can't be the second line. Okay. You'll get it. It's okay. This is one of the toughest one. It's okay. If I'm touching the boundaries a little bit, yeah. Yes, tell me. It knows that it has to, when someone comes and see, I will tell you one thing. You wrote a logic here to go to database, find the name and everything using the ID and come back here. Do you have to write again everything here also? Because he is also passing employee ID here. Just call the above one, right? Just call the above one. But he doesn't want the name to be in the database. Only name should be changed. Got it? Name should be whatever the name he is just passing. Yes, three constructors.
So if I'm calling this dot employee ID and 3 has employee ID and there is another constructor and it also has employee ID. So which constructor it will call?
You can only call one constructor. So you should put, for example, I have this one. For example, very good. I will tell you. I have this one.
There is another
Double. Yes, I got it. Double salary. Why don't you call the second one? Second one is calling the first one already. Got it? Only one constructor call is allowed. Okay? Got it?
This means always the one which you are calling.
Signature. Signature is matched. Method overloading. Signature is different. Overriding signature is same. Overloading signature should be different. Agreed? You learned a lot today. Okay. Yes, that's it for today.